let's do an example now. So in this example, we want to estimate the area under 1 over 1 plus x squared from x equals -2 to x equals 2. And here you can use your calculator or your calculus superpowers to plot the curve, which is something like this. Okay. It has a maximum at 0, and then it decays asymptotically towards infinity and negative infinity. And let's say -2 is here and 2 is here. Yeah, somewhere here. Okay, so we want to find this area here. Okay, that I'm plotting the exact area we want to find, but we don't know how to do that yet, so we need to estimate it. All right, so let's estimate using left endpoints first. Here first, well, let me do a picture and then we make a few decisions. You see? So here, there we go. Go from underestimating to overestimating. Okay. All right, so I was saying we need to make some decisions here. So the first thing we need to decide is the number of rectangles. So let's take n equal to 10, for example, 10 rectangles. And let's see what is the corresponding width of those rectangles. That is b minus a divided by n. That is 2 minus -2 divided by 10. That's 4 divided by 10, so 0.4. In this type of problems, you know I don't like decimals, but in this type of problems, we need to use decimals, okay? Otherwise, it becomes unmanageable. So then x0 is -2, x1 is -2 plus delta x, which is 0.4, or -1.6. x2 is -1.6 plus 0.4, so -1.2, x3, x4, -1.2 plus 0.4, that's -0.8, plus 0.4, that's -0.4. Okay, then x5, which is -0.4 plus 0.4, that is 0. We are here right now. So this would be x5. Okay. So x6 is 0 plus 0.4 gives 0.4, 7, 8, 9, and then 10. So this is 0.4 plus 0.4, that's 0.8. 0.8 plus 0.4 equals 1.2. 1.2 plus 0.4 makes 1.6. And then 1.6 plus 0.4 makes 2. Which is the endpoint as we wanted, okay? So all good. Remember in the previous video, we said that instead of memorizing the formulas, we just compute that on the spot. That's what we did here. So for example, this would be -1.6, -1.2, and so on. And then we have 0.4, 0.8, 1.2, and so on, okay? So that's how we find the points. And here, now we need a bit of patience and I use calculator to compute the sum with the left endpoints. Okay, so this, remember, was delta x times f of x0 plus delta x times, it's always the base times the height, base times the height, f of x1, and so on. Remember, we wrote it as delta x times f of x0 plus f of x1 all the way to f of x. And here you may not be sure if you should write x10 or x9. I tell you it's x9. Okay, let's write it here too. You just need to look at the picture and say, okay, the height of the last rectangle, this one here, is the point on the left, which is x9. Okay. Almost there. Now this is a lot of fun. So 0.4 times 1 divided by 1 plus, and here we need to plug in x0 plus 1 divided by 1 plus negative 1.6 squared, and so on. 1 divided by 1 plus 1.6 squared, that was x9, and that's it. And here we do all these computations. 0.4, I actually computed it, so let me write what I got. 0.2 plus 0.2809, and that's it. Here I used the magic of video, so I just completed all of it, and then you can see the final result. Here you can use Excel, for example, if you know how to use it, or just the calculator. In case you are thinking how to do this in a problem you will not be usually asked to do such a large number of rectangles, okay? It will always be something manageable. But once we compute all this, the sum of all these times 0.4, we get to 0.2097. Okay. And we can do also the right endpoint sum, which is delta x times, here we start fx1 plus fx2 all the way to fx10. Okay. And that means 0.4 times 1 divided by 1 plus negative 1.6 squared plus 1 divided by 1 plus negative 1.2 squared plus 1 divided by 1 plus 2 squared. And we just keep going. Okay. 0.4 times, and here we compute all the numbers. There we go. And once we have all these computed, we just compute the sum, multiply by 0.4, and we get 2.2097. Okay, and I did with so many rectangles because you see what happened here? When we did a good approximation with a lot of resolution, quote unquote, okay, we actually get 4 digits good. Okay, 2097. Okay, so it's actually, you see how this works. It gives, the more we take, the better the approximation, and in the limit, we're going to find exactly what is the area. But we can get an approximation as good as we want. It's just a question of using the computer to compute the area with more rectangles.